about the concept orbitals. So far you have come across with different atomic orbitals and it's the way how the electrons are moving around it. You could see in Rutherford's atom model how the atom was represented and how the electrons were revolving around the nucleus and how it failed to explain the stability of atomic orbitals. And then we have come across with Bohr's atom model, and then again Bohr's atom model and its orbital structure became a question for principles like Heisenberg's uncertainty principle and the dual nature of microscopic particles. Like this Bohr's atom model could not explain, or the orbit, the movement of electrons in that particular specified orbit could not explain the wave nature of electrons and it's the ability to find that simultaneously how can we find out the momentum or the position of that particular microscopic particle like electron at a stretch. It is impossible. So it became a question. It became a question about the existence of Bohr's atomic orbital. So now we are moving to another important section, that is an idea about orbitals. As we have already told, science is always movement from one knowledge to the better knowledge, always seeking the better knowledge about something, or always seeking something the unknown in a better way. And we are not denying what we have at hand. So we are not denying Bohr's atomic orbit or Rutherford's atomic orbit, and we know about it, and we are having a better understanding about whatever they have stated by using another concept which is known as orbitals. And this orbital concept could prove or could satisfy the dual nature of electrons as well as its Heisenberg's uncertainty principle. Okay, so we will see what is an orbital. Orbital is that region of space around the nucleus where the probability of finding an electron is maximum. So now onwards, orbit is no more a spherical shape, or orbit is no more a fixed round circle for you. But what is an orbital? Orbit concept came to a better, delightful concept, that is orbitals. That means it becomes the presence of electron is not going to be in a fixed circle at all. You can see here, this is the orbit concept you had so far. But this is going to be ruled out with a better understanding about the movement of electrons around the nucleus. That is, the probability of finding the electron in a region instead of in a particular circle. So, this exhibited or this particular concept of orbitals is represented. It can be represented by different means, but for a better understanding, it is represented by dot structure. You can see here, dots are presented in that whole sphere, and the density of the dots will be different from place to place. So, where the density of dots are more, there the probability of finding the electron also will be more. As a whole, the whole area can be somewhere will be the presence of, you can find out the presence of electrons. And this particular representation is known as electron charge cloud. So, an electron charge cloud is represented by the dots. And where the charge cloud is more, there the probability of finding the electron will be more. Okay? That is about orbitals. From the very definition itself, it's clear for you that orbital concept has a lot of difference between orbit concept. So let's see those differences as in a listed manner. So you can say, first of all, orbit is a well-defined circular path around the nucleus in which the electrons revolve. You know that it is around the nucleus, it will have a well-defined circular path. That is orbit. But orbital is a three-dimensional space around the nucleus within which the probability of finding an electron is maximum. That means it is not a plane structure. It is not in plane. It is three-dimensional. You know the difference between something that is written or something that is shown in the plane and what is a three-dimensional. That means it will project the front, back, sides, every side. You cannot just keep it in a plane. So Orbital will show the presence or the probability of finding the electron in a three-dimensional space, not in a plane, like just a circular path that is shown in the orbit. Now, second difference is, orbit represents the planar motion of an electron around the nucleus. In the plane it moves, it's a planar motion. In the given plane, it shows that electron is revolving around the nucleus. While the orbit represents three-dimensional motion of an electron around the nucleus. We have already told it represents the probability of finding the electron in a three-dimensional space. That means electrons are present and electrons are moving in three-dimensional space, not in a plane. The concept of orbit is not in accordance with the wave character of electrons and uncertainty principle. We have already come across with this. Uncertainty principle and the dual nature of matter questioned the presence of orbit or the concept of orbit in Bohr's atom model, because it was only explaining, or it was only relying upon the particle nature of matter, particle nature of electron, as well as we know that the momentum and the position of a moving electron cannot be determined simultaneously. So, this orbit speaks about both the position and momentum at the same time, considering both the position and momentum at the same time. So, it was not in accordance with the Heisenberg's uncertainty principle, as well as it was not speaking anything about the wave character, not giving any idea about the wave character of electron. But the orbital concept is in accordance with the wave character of electrons and uncertainty principle. So, the concept of orbital could fulfill both the concepts. That is the concept regarding the dual character of electrons, as well as the uncertainty principle put forward by Heisenberg. And then all orbits are circular and disc-like. We have seen the structure of orbit is circular around the nucleus. This circular and disc-like. This is the shape for all the orbits. But in the case of orbitals, different orbitals will have different shapes. S orbital will have spherical shape, and P orbital will have dumbbell shape, and D orbital will have double dumbbell shape. Now, the orbit do not have any directional characteristics, that it will not point towards, because we have already told all orbits are circular and disc-like, and it is not pointed towards a particular direction, X or Y or Z direction. But in case of orbitals, all orbitals except S orbital. Why except S orbital? S orbital is having spherical shape, so it do not have any, it is not pointed towards any axis. So all orbitals except S orbitals have directional properties. They are pointed towards either X direction or Y direction or Z direction. So it has got directional properties. In the case of orbit, the maximum number of electrons in an orbit is given by 2n square. We have already learned about it. If n is the principal quantum number value, n is 2, you will get the number of electrons is 2 into 2 square. Okay? That was the way how you were finding out the number of electrons present in an orbit. But in the case of an orbital, the maximum number of electrons present in any orbital is 2. Okay? The maximum number of electrons present in any orbital is 2. But in the case of an orbit, the number of electrons present in the orbit should be calculated by using the equation 2n square. But in the orbital, it is not like that. Any orbital you take, that will be containing only 2 electrons. So this is all about orbital, the concept of orbital, and you know what is orbit, and we have come across with the difference between the orbits and the orbitals in a detailed way. I hope you have understood the concepts and you are clear about what we have discussed. So we will see again with new ideas and concepts to add to your knowledge. Thank you. See you again.